We all have played games on our desktops, laptops, tablets, or mobile phones. Do we enjoy them? Yes, we do. Games are addictive and command our attention. And this is one of the reasons why even your web browser shows a game when you do not have an internet connection. A lot of you might have discovered it when you hit your hands in despair on the spacebar. But how many of you have created games? If you haven't, today is your chance to do so. Hi everyone, thanks for joining in. I'm your host, Malagupta. Today on IntelliJ Idea Livestream, I'm pleased to welcome Almas, who will talk about how you can use Java and Kotlin to create games using FXGL, which is a gaming engine that extends JavaFX. Almas is the creator of FXGL, the gaming engine that he'll talk about today, and he works as a senior lecturer in game development with University of Brighton. Hi Almas, it's a pleasure to have you present today.
Hiya, thanks for having me on this live stream.
Almas, if I may ask you, when and why did you start working with FXGL and why JavaFX?
Well, this story goes back for about 5 years ago when I started teaching game development using various languages, including Java. And essentially, I started with a bunch of classes using JavaFX to just teach the basics, such as the main loop in game development. And then as I kept building this into my lectures, it actually grew into just a small library. And then I thought that could be useful for other people as well. And that was then the decision to open source it and make it into a library. Since then, it's been growing, and we've got 5 years of development time put into this engine now, and it's reasonably robust. So I'm really excited to present it.
That's interesting because I started my career as a Java developer in Swing. So this is exciting to me as well. And one fun fact about Almas, when I was talking with Almas, I discovered that he has an external hard drive that stores almost all data that was deleted into the recycle bin since 2007, just in case. I think all of us have done that. So, Almas, what is the count of those external hard disk drives now?
It's actually 2.
Oh, that's great.
Because all that gets deleted is mostly text files and just plain text files, source code.
Okay. And before I let Almas take the stage, let me share some quick housekeeping details. Please use the YouTube chat to post your questions. Almas would not wait till the end of the session to answer them. I and Andre from the JetBrains team will answer your questions as you post them. The session will be recorded and hosted to IntelliJ Idea's YouTube channel. So if you haven't already subscribed to our channel, please do that now. And if you like today's session, please do not miss to hit the like video. Where's my camera? Yes. Almas, let me add your screen to the stream, and I'll let you take the stage now.
Okay, perfect. Thank you. Hi, everyone. I'm Almas, and today I'll be talking about the FXGL game engine, which is a game engine written in Java and Kotlin, and provides APIs for both of these languages. So we're going to see how to make a simple game in it. We're going to see various features that FXGL provides, and we're also going to see a little bit of a deep dive into some of the low-level technical details. So it's going to be suitable for both those who've never heard of FXGL before this talk, as well as for those who've done something with it. And before going any further, I'll just very briefly introduce myself. As Mala said, I am a senior lecturer in game development at Brighton University in the UK. My PhD is in computer science. It's about visualizing network and set data using Euler diagrams and graphs. I'm the author and maintainer of the FXGL game engine, which is what we're talking about today. And I've got a YouTube channel which focuses on a range of technologies, including JavaFX, Java, Kotlin, and a bunch of other things. So we're going to start with an introduction to the engine, so what the engine actually is, how it works, and then we'll proceed with the overview of the features that it can provide. And throughout the presentation, there will be a few places where I'm going to demonstrate a few things. So what is actually FXGL? It's a high-level framework / engine that aims to make JavaFX game development considerably easier. So this is the overall aim of the engine, and it achieves that through a range of features that it provides. Particularly, some of the things that we can consider as being the unique selling points of this engine is that there is no installation required, and there is no setup required per se. So you just add it as a Maven or Gradle dependency, and it's ready to go as an external library. It supports all major versions from Java 8, going all the way to 16. 8, 9, and 10 are considered legacy at this point. So starting from Java 11 and higher, anything any major version from that is supported. The platforms, Windows, Mac, Linux are kind of a given because we use JavaFX as the rendering pipeline. That means any desktop OS should be fine. We can also compile to mobile, and that's courtesy of Gluon, various tools that Gluon provides, and we'll look at that later on. Embedded and the web, these are supported, so FXGL actually works on these platforms, but they're not quite production ready just yet. FXGL is a strict superset of JavaFX. That means if you can do something in JavaFX, you can also do that in FXGL. And this comes with a big advantage. If you know how to build a JavaFX app, you don't need to learn a new API, particularly relating to user interfaces, because at this point, FXGL and JavaFX are almost interchangeable in terms of user interface. And because of that, FXGL plays really well with other JavaFX tech, like GluonFX Maven plugin, JavaFX Maven plugin, JPro, and other tools. So with FXGL, you can build any 2D game, you can build some 3D games, and you can also build a range of business applications. So any kind of application that has a front end, you can build using FXGL in both Java and Kotlin. The license is quite suitable for anything. Well, it's MIT, so you can use it for hobby projects, academic projects, or commercial projects, and you don't need to worry about licensing. Games are packaged into a single executable jar, or more something that has been more common these days is native images. So we can produce native executable images for a specific platform. This is mainly the academic community around FXGL. We've got a bunch of academic institutions who've told me that they are either using FXGL at the moment, or they've used it in the past to teach computer science, software development, game development, and the list is growing. So if you would like to use FXGL to teach at your institution, then just drop me an email, and we can figure out the most effective way we can do this. So in terms of what features it has, it's a game engine, so it will provide you with all the features that a typical game engine can provide you with. And that starts at logic. We've got game objects, game world, game state, has AI elements like pathfinding, navigation, planning, decision-making, physics, gameplay, user interface, obviously graphics to be able to render interesting scene graphs, networking, hardware access, and integration with external tools that are designed for game development. And we're going to look at some of the examples from these features, particularly the major ones, because at this point, it's grown to include so many features that I won't be able to actually condense all of them into a single talk. We'll just focus on the major ones. In terms of the modular architecture, as in Java 9 and higher modules, it's fully modular. That means you can build fully modular applications and rely on the FXGL module in your module info.java. And that's the only module you need to include. It will transitively include everything else. So some of the links that will be posted later on the YouTube video that you can have a look at. It's fully open source. That means you can just go, you can Google FXGL, and the first thing that comes up should be the GitHub repo with all the source code for the engine. Right, so hopefully at this point you're wondering what the minimal example looks like. And it's exactly what you can now see on the slide. So it has, well, the good news is it fits on one slide, so it's easier to talk about it. And if we're looking from the top-down perspective, then we can see that our class needs to extend game application. In JavaFX, you extend application, so it's kind of similar. The only thing we need to override is the init settings method, in which you provide a range of settings like the width of your application, the height of it, the title, version, and a plethora of other settings that will configure your game as needed. And the other method, I suppose, is public static void main, which we should be all familiar with. So I don't think we need to explain that. In which case, you can see that it's reasonably easy to get the hang of the minimal example as it's currently written. So starting from this slide onwards, we're going to look at various features, various systems that are built into the engine, and what kind of things you might utilize for your either game or business application. And we're going to start with the 3D mode, as it's been quite popular and it's a recent addition as well. FXGL provides a range of built-in custom shapes, which you can see on screen. These can be combined to form composite shapes, and you can do stuff like that, for example. So you can take your primitives, combine them into this shape that you can see, and you can do something with it. You can either display it in the scene graph or animate it. Animation is a thing. So you can produce your 3D shapes, you can animate them to produce even greater effects. And there is also API that allows you to manipulate each vertex. So previously, we were changing primitive shapes within the complex shape. And with this, you can actually change each individual vertex in the primitive mesh. So you can obtain a range of interesting effects. In the top left, that's a torus that's been kind of morphed into this interesting shape. In the middle, you can see the blue, it's actually a cylinder. And then I think it's a pyramid in green. The same API also allows you to produce custom shapes at runtime. So this flower-looking shape is actually a cylinder. It's been changed, or the vertices have been changed to produce this visual effect. And it essentially allows you to produce any kind of shape from any primitive. well, up to isomorphism, that is, because you're not actually changing the number of vertices or edges. You're changing the position of these vertices. And 3D can be combined with other systems that FXGL has. So this one, for example, it's a procedurally generated world, and it's been generated using Perlin noise, which gives you something like this, which you can then render in 3D using primitives, using cuboids or cubes. And you get a Minecraft-looking example. Alternatively, you can use the maze generation algorithm and combine it with, again, 3D rendering to get yourself something like this. It's a 3D maze, essentially. So you can produce a clone of Doom, or well, the early versions of Doom, I suppose. You can get more complex scene graphs by combining FXGL with FXYZ, which is a library that deals with a lot of the 3D computations and model loading. So if you need to load external models and do some animations with them, make them into essentially like a demo inside a game, then you can have that as well. And this is a screenshot from a demo made earlier. Right, so on to some of the concepts now. Everything is an entity. That means everything that you can see right now on the screen, the player, the bullets, the laser kind of things, the particle effects, the enemies, the explosions, the border, the background, everything is an entity. Think of it as a Java object, like the object class, which is the parent of every object in Java. So everything is an entity, and there is almost no way to distinguish two entities from each other by just looking at them as objects, because they don't have any fields or methods. Yeah, think of it as a Java object that doesn't have any fields or methods. And the way you transform an entity into something that you want to use in your game, you add components. Components are the things that hold data and behavior for each entity. So you can add fields and methods to your entities at runtime. And that's quite a powerful paradigm. You're able to add and remove fields and methods to any entity that you want in your game. And that's how you make an entity into a player entity, or that's how you make an entity into an explosion entity, for example. Another term for an entity is game object. That's how it's used in other engines. So Unity calls them game objects. Unreal Engine calls them actors. This is an example component. You can extend the component class, and then you can provide your data, such as the X and Y values. And then you can also provide behavior, which is essentially a method. And then you're able to then query if a certain entity has a certain component, and then you can typecast it to your component that you need to work with, and then do the things that you need to do. In terms of physics, which also use this entity component model, we've got two versions for physics. One is lightweight, the other is heavyweight. Lightweight is used for collision detection. That's when you want to know if two entities are overlapping. And if they are, then they are colliding. So we want to do something like play a sound or collect a coin if your player entity is colliding with a coin entity. And there are a range of implementation techniques that are used for collision detection. The common ones are bounding box and separating access theorem that are used to check for collisions. And we also have the heavyweight physics, which is implemented using an adapted version of JBox2D, which is a physics engine for simulations. So for that, I actually have a demo, which I'm hopefully going to run. My internet connection isn't great, so this is going to lag a bit, so bear with me. So we now have these entities, and you're able to collide with them or simulate physics with them by just throwing another entity into them. And this is where the physics simulation comes in, which is driven by the JBox 2D physics engine. So this is quite easy to implement, actually, using FXGL. And using a similar method, you can build a snooker game, for example, because essentially you're also simulating physics. This will probably be a slideshow on your screens, but rest assured, it is running at 60 frames per second. It's just the internet connection giving it an interesting twist. All these demos and the source code, all of that is available from the FXGL repo on GitHub, and there will be a link to that later, so you can test it out for yourself. Right, so back to what we're talking about. So heavyweight physics, lightweight physics, two different ways to perform various physics-related activities in the engine. And this is the snooker table that we just saw earlier. Now on to AI, or how entities actually do something. You can manually apply, call methods on your components to give them some logic. Or if you want your entities to do something almost on their own, then you need AI. And this is provided by the finite state machine component in FXGL, which is sort of the simplistic representation of AI, where you have different states that you need to go between, so such as running, hiding, crouching, and so on. And in terms of pathfinding, we've got A star grid, which is like any two-dimensional grid, where cells are marked whether they're walkable or not. And then when you set an entity to those cells, then you're able to say, well, I want this entity to go from cell A to cell B whilst avoiding all of the obstacles in between. And this is where the A star algorithm will kick in and then say, well, actually, this is the shortest path between A and B. Let's kind of follow this path. Almost all of the implementation details are hidden. That means you only work with quite high-level API, and because that's one of the goals of the engine. Onto the UI bits now. Because we integrate with JavaFX so seamlessly, complex UI is actually quite easy to achieve. So something like this, you can easily build. And this is from a game called Card Combat. And it is one of the games from the FXGL games repo on GitHub. The source code for which is given, and you can browse it, you can build it, you can modify it. Again, the license is quite permissive with regards to what you can do with the code. The engine comes with a stock menu, which looks like this. It's not much, but you can customize it in any way you like, and that's where the advantage comes from. So this is the stock menu, and you can see using your scene factory, you can provide your own custom menu. All you need to do is provide your own class that extends the FXGL menu, and you're good to go. And you're able to produce something like this. which is essentially the same menu that you saw earlier. It's just, well, it just looks different. In terms of functionality, it's exactly the same. It's still calling the same callbacks. It's just visually different. And this is where the customizability advantage comes from. Again, it's exactly the same menu, slightly different menu options, but visually different, functionality-wise, same. And there is a bunch of dialog boxes, which are again built in. All you need to provide is the message and some callback. This is just a message box, a confirmation dialog, such as yes or no. So you want to ask something and you want an answer. The answer is given to you as a Boolean. You can take some input from the user, which allows you to communicate sort of both ways. You can display something to the user, and you can also take some information back. And as with any other system in FXGL, we have a customizable box, which means you can add any number of UI controls and customize it in any way you like. In terms of isometric views, commonly known as 2.5D, there is no specific built-in support, but you can still produce something like this by just using the maths provided in terms of where you want to place each of the tiles. And in terms of sort of low-level details, that's kind of the slide that will start introducing some of the low-level details. This is I/O task paradigm, or exceptionalist I/O paradigm, which you will have seen in different bits of JDK and other libraries. Essentially, you wrap the code that can potentially fail with your I/O task, and then you provide two callbacks. One is success, the other is failure. And the produced task object that you can then run either asynchronously or with a dialog, or asynchronously, but with callbacks being called on the JavaFX thread. You need JavaFX thread because to modify the scene graph that is live, as in user interface, you need to run some of the code on the JavaFX thread. And again, we take that immediately from the JavaFX platform guidelines. So essentially, as I was saying earlier, FXGL is very synonymous with JavaFX. Some use cases for how you might use this I/O task. You can run your AI, for example, in a background thread, with the results being then conveyed to the UI thread. In terms of networking, both for TCP and UDP connections, there's exactly the same API. The only thing you change is you just you tell FXGL whether you want a TCP connection or UDP connection. Everything else is going to be quite high level. Everything is isolated with callbacks. The actual implementation is the JDK vanilla implementation of TCP and UDP, so no change there. But with high-level callbacks, it's much, much easier to build a communication between two machines over the internet. And using that networking service, we can also have a multiplayer service which builds on networking and allows you to synchronize your games across multiple machines. This is called replication, where you take the state of the game on one PC, and then you can replicate that same state on a different machine, potentially over the network. So if you want to build a, say, 2-player or N-player multiplayer game, you can use this replication, and it's going to synchronize all the entities across multiple machines for you, essentially. You don't need to kind of do much. You just build the game rather than building this networking communication. And while we are on the networking theme, there is also API for downloading files, which is useful if you tend to keep your assets somewhere on the server and you would like your players to download these files from your server rather than distribute them. This is beneficial if you want to be able to update your assets, for example. Right, so particle systems, or particle system rather. This is a highly customizable particle system. It allows you to produce really stunning effects with very little code. And this is what you can see on the screen is produced by a built-in emitter. You just create an emitter and then you pass that to the system. Now, using the same emitter, or rather with slightly different configuration, you can obtain something like this. Admittedly, this looks different, but actually implementation-wise, it's pretty much the same. You've just changed a few things. And we take that, we change the blend mode to, say, add, and the rendering then of the particle system changes to something like this. So you can get a different effect with different blend mode. Blend mode refers to how the particles are going to be drawn on top of each other. And here's a bit of code for that. We've got, you create the emitter and then you provide various configuration settings. And that is essentially it. Now on to animation system and interpolations. So the animation system is actually separate from the particle system. In fact, all the systems that are built into FXGL were designed to be separate and standalone. That means you can mix and match them quite easily without them interfering with each other. And so you can use your animation system to, say, animate a node, a just standard JavaFX node. And the API to do this is what you can see at the moment. You can also provide interpolators, which change the rate of the animation, and there are quite a few built-in ones. So you can just play around with these. And this very same animation system extends to 3D in a very obvious way. The only thing that changes is your coordinate system goes from 2D to a 3D coordinate system. So you just add the Z value to your X and Y. Everything else is more or less the same. The API is the same, which means that you don't need to learn anything new if you want to kind of change between the two dimensions, 2D and 3D. And because of the seamless integration between FXGL and JavaFX, we can produce, well, we can combine them. You can use standard JavaFX canvas to draw stuff, and you can then combine that with the animation system built into FXGL. So this is a tessellation produced using this combination. And it's reasonably easy to do as well. And again, you can also animate fractals using JavaFX Canvas, and you can interpolate the positions of your drawing coordinates using the various interpolations that are available within FXGL. You also get some profiling tools. They're not extensive, but they're getting better. They'll tell you how fast your application is running and where you might find your bottlenecks. So the frame rate, how much time the CPU took to compute the last frame. So these are the things that are commonly provided. We can localize as well within FXGL if you want to support multiple languages. Ultimately, you produce a bunch of key value pairs in a file called .lang. It's essentially a property file, property bundle that gets loaded at runtime and then automatically bound to the UI, which means when you change the language within the game, it automatically changes all of the text for the user interface. In terms of serialization, that refers to saving and loading game state. Again, all of the stuff is kind of hidden. All you need to do is provide a map-like data structure or populate it, and then you can use the save load service to save or load that file, and then you can sort of restore game state. So onto cross-platform support. So as you may know, Gluon attach library provides hardware access to mobile. And using that, we're able to access the file system and various other things like the accelerometer on a mobile phone, so you can control with it, for example, the touch screen. And FXGL hides all of that again. It gives you this wall of API that you target, and everything else is hidden. And this is an example, this is a breakout example, and this is a slightly complex example of Space Wars, also running on mobile. In fact, this is running with zero code change. So the same desktop configuration of 1080p, all particle rendering, all the stuff set to max quality. It runs at about 60 frames per second on a mobile phone, which is quite good. And it's getting better. So hopefully it'll be constant 60 frames per second in future versions. And we can also run FXGL games or apps on Raspberry Pi. And this image is courtesy of Frank, who does a lot of stuff with Raspberry Pis, with JavaFX, with FXGL. And this is a Snake game, or a clone of Snake, using FXGL and running on the Raspberry Pi. So as I was hinting at earlier, FXGL is not just for games. You can build any application that you want. Has a front end. On the left-hand side, there is the Twitter network visualization, which is also animated and interactive. On the right-hand side, we have a hub tool for community JavaFX apps, but it's going to be superseded by JFX Central very soon. So people should be using JFX Central. But still, the point is that FXGL can be used to build just normal applications as well, not just games. This is another example of a non-game application, which is a dialogue editor, although this is related to games, admittedly. You're able to build these complex dialogues between characters, between NPCs in your game, and say an RPG game, role-playing game, in which you can then also run the dialogues within the engine to see how they would play out and just to get a feel for it. So there is a range of tools that you can build with FXGL, and there is a range of tools that is already available as well. Tiled map support. So this is support for external tools. Tiled map editor is a popular 2D editor for games. So on the right-hand side, you can see the editor itself. You can use that to build your level, and then using FXGL, you can load that into your game. And then you don't need to have any sort of placement issues. You're building your level within the editor, and then you're simply loading it into FXGL. And that's how you might do that. So you've got your entity factory that tells FXGL how to produce your entities. And all you need to do is just to provide the file name from which to load. And here's an example of what it might look like, which combines both static and dynamic entities. Static being the ones that are part of the level, dynamic ones that are created at one time. And we can also render quite large game worlds. So this is Zephyria RPG, which is actually built in Kotlin, and it can render quite high density, high resolution images. You don't actually see the full image. It gets trimmed, but it's being trimmed at runtime. So that is still possible to get 60 FPS even with that. And that's essentially part of the JavaFX rendering pipeline. Just a statement to say JavaFX is really fast. On top of that, FXGL also simplifies some of the things, such as sort of baked post-render effects. So you can use different blend modes and you can pre-render them so that when you're actually displaying them to the screen, you don't have the overhead of blending. And this is what the editor might look like in the future. I mean, 5 years isn't that much in terms of development time. So it's still quite early stages for the engine itself. But this is what the editor may look like in the future. And it will allow you to build games without touching the code, essentially. Right, so at this point, I'm going to do a quick demo. So if I go to this, we're going to build a simple example with FXGL. And I'm going to do this reasonably slowly so that the internet connection can keep up. All right, let's get rid of all the noise. As we saw earlier, we need to extend the game application class. We then need to provide settings, which I'm not going to do because there are default settings there. And then we're going to launch. So you can see that in order to build the most minimal example, you don't actually need a lot of code. The only thing that you do need is just to provide the entry point. And you can then start this, and you're going to get a default application. So this is a window with nothing in it. It's a 800 by 600 default titled game, so to speak, with just white background. We're going to add one entity, and that's going to give us a feel for how you would just develop stuff in FXGL. We're going to override init game, and we're going to use the entity builder to add an entity at 200, 200. 200, 200, that means X and Y. So these are the coordinates. We're going to say it's going to be a rectangle. I'm going to use the standard JavaFX rectangle for that. Let's go for 40, 40. So this will create a square. And we're going to build and attach. So that completes creation of the entity and also adds it to the game world. So just to reiterate, we've created an entity at 200, 200. We've added the view, which is a rectangle, and we've added the entity to the game world. So if we run this now we should see a 40 by 40 rectangle. There we go. So that's our entity, and that's the only thing it knows about itself. The view is the only thing it knows about itself, because we haven't added any components, which means it doesn't know what to do. It's just there, it exists. And that's what the entity component model does. You provide behavior and data using components. Right, so back to our slides, and we can finish off. These are just some of the examples that I was going to show if my live demo didn't work. Right, so in terms of the summary, there are two key takeaway messages from this. FXGL seamlessly builds on top of JavaFX, and we've seen that. We can use JavaFX nodes and everything as needed. And FXGL makes app/game development easier and more robust by providing access to real-world tools and techniques. And hopefully this simplifies the whole process of the development itself. Just a quick note on the book that's being written, or at least it's being designed. And hopefully it will come out sometime after May 2022, so May next year. And some of the things that will be covered are the things that we just briefly touched upon. Right, so if you want to be involved with FXGL, it's a fully open source project, so you can engage with it on GitHub. Any of the following ways is a great way to contribute. You can crash test features for bugs or write a unit test. You can create an issue or suggest a feature. You can provide an implementation of an issue. You can sponsor the project, which starts at $1 a month, and you can cancel at any time. You can proofread documentation for errors. And finally, you can start a project repository to show interest. On that note, thank you for listening to me talk about FXGL, and I'm happy to take any questions.
So first of all, thank you so much, Almas. What I really like is that it was, because being a presenter, I know that it's not the kind of easy to demonstrate and talk about the possibilities with the gaming engine that you did in 50 minutes. That was great. So you did a great job. And we have a lot of good comments about people, they are liking about the capabilities of the engine. And of course, we do have a lot of questions. So let me start with the questions which are talking about, so a lot of developers, they are concerned about the performance of the games that they would develop with using this gaming engine. So one of the question is, just a moment. Okay, is the hardware acceleration in JavaFX finicky, or am I just too old to see if it's good now or not? And how does the hardware acceleration fare here? Because one of the developers mentioned that they remember JavaFX having some issues like this. Like, what would be the performance compared to LWJGL, if you're already aware about that?
Yeah, okay. So first of all, it will highly depend on the actual use case. There are some use cases which probably are not feasible to do with FXGL. For the majority of use cases, the rendering performance should be fine, which is one of the reasons why I included the rendering large images slide. Now, I think the easiest way to answer this would be to build a small example of capturing the use case that you'd like to build. It could be maybe half a day or a day at max to spend on getting to see how FXGL rendering performance would work in that use case. And then that should give you an informed decision in terms of whether it is possible to make a game in it. specifically your game, I suppose, because so far I haven't hit the performance bottleneck just yet. Most of the performance bottlenecks I've hit so far are CPU bound. So things like physics or AI, mostly physics, and also the number of entities that are simultaneously present in the game world. So you can go up to about 2,000 entities if we're being careful. And I think that's a reasonably good limit. Like, you wouldn't normally have 2,000 things on your screen at the same time, as in game objects. You might have particle effects and such, but you wouldn't have 2,000 game objects normally. So from that perspective, going back to the question, it's likely dependent on the use case, but so far it's been quite well. In terms of whether it's finicky or not, the rendering is actually hidden. So we never talk to the GPU directly. We always use high-level rendering objects. So think like textures. If you want to have images, then we load images as assets. We provide those image objects to our entities, and that's how entities exist and get drawn. We don't actually say, GPU, draw this kind of thing. Generally speaking, JavaFX has improved in that area, particularly on mobile phones. So as I was saying before, the Space Wars example, which is rendering at 1080p with all particle effects, it performs almost at 60 FPS on the mobile phone, and the bottleneck there is still CPU bound. So I need to figure out a way to improve the physics performance and the game world performance. In terms of LWJGL, which as far as I can remember uses OpenGL bindings, that's probably going to be very similar in terms of performance. It actually depends, because with JavaFX, it's quite easy to write suboptimal code, which is where all the kind of performance issues come from. And it's tricky. Yeah, I suppose I can kind of get what you mean by finicky. You kind of need to know what things you can use and what things you can't use, because if you render them in a very specific way, you're going to get very good performance. If you render the same thing but in a slightly different way, you're going to get terrible performance. So from that perspective, it could be finicky. But in terms of direct comparison between LWJGL and FXGL, it's up to the use case, I suppose. Because we still do use OpenGL, say, on Mac and Linux. And on Windows, it's Direct3D that's being used by JavaFX.
Right, that's, as I said, fair enough. The other question, as I mentioned, the developers, they really liked all the possibilities and the demonstrations that you had in the session. But there were a couple of questions which kind of hinted towards the same question, is about the future of developing games using this game engine. So one specific question is, what do you think about developing games professionally using this engine? Is that a good option? Does it has a bright future?
I'm inclined to say it depends. That kind of seems to be my default option to all the questions. Definitely not AAA titles. That's as far as I know, because if you want to build a AAA title game, go with Unity or Unreal Engine. That's just much easier, because you get all the cinematic options and everything else in terms of rendering, support, and Unreal Engine 5 came out just recently, so all the goodness is over there. If we're talking professionally in terms of indie, kind of small 2D games developed by a single developer or small team of people, that's absolutely fine. Even at this point, like not in the future, but at this point, FXGL is reasonably robust to be able to handle a range of use cases, not just a specific set of use cases. So yeah, the answer is if the game that you're building is not AAA title, is not going to be graphically impressive, then it should be possible to make it in FXGL, is what the answer is.
That was an honest answer, and as you mentioned, it's just 5 years that you started working on it, and you are adding more features to it. So probably later sometime
And hopefully
you
we can get even more developers working on it as well. It's open source after all.
yes, absolutely, that would make a lot of difference, I'm sure. There were a couple of questions regarding bundling the application and working with other frameworks. So there was one uh, question which was specifically about including JavaFX in. So is JavaFX bundled with the Java, not Java, FXGL distribution?
Yes, the only thing you need to depend on in your Maven POM file or in your build Gradle file is FXGL. So there's only one dependency ever. Everything else is automatically included. Particularly with Maven, because with Maven, everything else gets transitively included, which means you only
Yes.
depend on FXGL. Everything else, like JavaFX and other things that we use, gets pulled in automatically. With Gradle, it's slightly different. You will need to add a clause there to say, I want these modules to be present. But yeah, generally speaking, JavaFX is bundled with FXGL.
Right. So one developer also wanted to see your pom.xml. So I think they can do that by visiting your GitHub page, and they would be able to browse
Yep.
through the repos.
FXGL games is probably a good one because the FXGL itself is only going to contain POM file for the FXGL build rather than a game built with FXGL. So FXGL games repo is what you want.
Right. And I shared the link that you shared with me regarding the one which had the demonstration of a lot of games that you shared. So I shared that a couple of times, and I think people were liking it.
Cool. Yeah, that's the trailer so far. Well,
Yeah.
it was a trailer that was built several months ago. We've had a few more additions to the engine since then.
Right. So the other question is about the targets. I think you covered that in your presentation, but let me ask you that again. Does the game, it goes to iOS and Android? And if so, what does it use for getting the Java to iOS?
So in terms of target platforms, we have Windows, Mac, Linux, the desktop ones, Android, iOS, the mobile. For Android, for both Android and iOS, it's the Gleon. I think they've renamed it. It used to be called Client plugin. I think it's called currently Gleon FX plugin. And that's the plugin that uses some of GraalVM to ahead of time compile Java code to platform-specific code. And that's what's being used under the hood. That's essentially for JavaFX applications. But because FXGL is basically a JavaFX application, we can do that too.
Right. So we have a lot of questions which are coming in right now. So one is regarding, as I said, working with the other frameworks. So this is, I build complex applications and we need some kind of, what is this? Some kind of DI framework. We are moving away from Spring and Dagger and might be using Micronaut. So would FXGL and Micronaut play together well?
I haven't tried the combination of both, and I can't say I have experience with Micronaut, so I don't think I'll be able to answer that.
Okay, fair enough.
But if you send me an email or a message and with a link to what Micronaut does or how to use it kind of thing, I can have a quick look.
Okay. Yes, of course. Anyone who's watching, and if they are not able to get the answers now, they can always ping Almas, and that's very kind of him.
Definitely. Yeah,
The other
email
one
me,
is,
find me on Twitter.
can you implement event-based actions similar to Unity ones?
Event-based, yep. So you can set up the whole thing as an event-driven application. So you can say, when this event happens, such as player death event, then play a sound event or something like that. There is the event bus system, which I haven't talked about. It allows you to register events and also register callbacks for those events, so that whenever that event is fired, every other listener, every other party will be notified, and then you can handle the events as needed. The whole kind of event traversal is done by JavaFX and its own event engine, which allows us to just piggyback off of it, which simplifies the whole process.
The next question is, would you say FXGL could feasibly be used to make small browser-based games or virtual environments? And does it work for 3D rendering style applications?
So the two parts of the question: for the web, it works. It just works, but it doesn't work for production just yet. So it wouldn't be recommended to use in production, mainly because of slight design configuration, design interference issues with the framework used to compile for the web. So if we were to change how FXGL gets to the web, that might be actually quite feasible. But again, I'll need to look into that first, because what I've been using so far is JPro, by the way. And shout out to developers of JPro. It's a really cool tool that allows you to run JavaFX applications on the web. But it's designed in a way that expects something to be rerunnable from the same JVM instance, which FXGL is not by architecture. So they're just architecture incompatibilities rather than implementation details. In terms of 3D, yes, you can render 3D things in FXGL. You can load .obj models at the moment. That's the only format that is currently supported. But in the future, we might support more formats.
Right. So the next question is there any tool like the scene builder for FXGL in near future to make the development faster?
Yes, it's the editor. It's not going to work as Scene Builder, because Scene Builder builds UI mostly. The editor is going to build the game world like any other engine, for example. Think Unity editor that allows you to drag and drop game objects, populate them with rendering information, add components. And that's going to be then integrated with the IntelliJ IDE. So you can write your code in IntelliJ, compile it, and then without restarting the editor, you're able to test latest changes from within the editor.
And there's a related question. What is the timeline for the completion of the editor that you just mentioned? So that was by another developer.
Yeah, there is no set timeline. So the way I develop this, it's essentially a hobby project for me, which means I prioritize issues based on what people want. And community is the main driving force of these issues. So during just last year, 3D support, for example, wasn't available in, last year. I did a talk at the JFX Days conference, where the community, the majority of the community was saying, well, 3D support is great, why not have it in FXGL? And since then, there's been a lot of support to kind of drive this implementation with design decisions, discussions, and all that kind of stuff. And 3 months later, we have 3D support in FXGL. So if there's a lot of interest in the community and there's enough support in terms of ideas, how to develop, then the editor is likely to be developed within a year. But again, it's kind of very flexible, I would say. Particularly now that I'm going to be focusing on writing the book. The book needs to be out at some point so that people can get familiar with the engine as well.
Thank you so much, Almas. There are a lot of questions, but we have already running out of time, already 5 minutes over. So I would stop now. Thank you so much for presenting today, and it was a pleasure to see all the demonstrations and to kind of get to know the possibilities. I really liked, so one takeaway from this presentation for me would be that I could spice up my JavaFX application. So even though I'm not kind of planning to build a full-fledged game, I could use a lot of points that you mentioned to have some simpler animations in my JavaFX client application, which is a big takeaway from me. So thank you so much.
Cool stuff, and thank you for having me here.
And everyone, thanks for attending and asking the questions. And stay tuned for our next IntelliJ Idea live stream on August 18. We have Marco Bella, who will talk about working with test containers. The session name is Test Containers from Zero to Hero. So you can join in to know more about testing your applications using test containers. No prerequisite knowledge about test containers is required. So until next time, bye.